sorting technique they have asked in the exam. So we are given 4 2 6 1 3. N here is 5. N given here is 5. We have 5 elements, right? And we need to apply the different passes. So what I'm saying is, students don't, if it is a 10 marks question, you have to actually explain all the passes, otherwise you will not score good marks. So this is the given set of elements, and n is 5. And number of passes are always equal to n minus 1. So if the number of elements here are 5, so the number of passes will be 5 minus 1, that is 4. So that is why you can see majorly pass 1 in this box, pass 2 again in this box, pass 3, and then last is your pass 4, and we have discussed the time complexity. So majorly you have got to know what we have to do. So first of all, identify the number of elements, and accordingly you have to make sure that n minus 1 passes take place. So what happens in the pass 1? Let's understand. So what we have to do in bubble sort, we have to actually compare the contiguous elements, right? Adjacent elements, and we have to see if a greater element is above the smaller element. If it is there, then we have to exchange it. So if we are comparing 4 and 2, we see that 4 is greater than 2. So obviously we need to swap it. So we will swap that particular element, right? So as we have seen in this case, we have swapped these two elements. Now what we will do, we will compare. So after swapping 2 and 4, now 2 is at this position and 4 is at the second position. Now we will compare 4 and 6, but 4 is smaller than 6, so there will be no swap. Then in the next case, what will happen? I will compare 6 with 1. We can see that 6 is greater than 1. So swapping will be required. So you can see I have put a tick here where swap is there. So swap is there. Here there was no swap. So I have put a cross. Here again there is a swap. So 6 and 1 will be swapped, and the new position will be 1 and 6 like this. And then now 6 will be compared with 3. And you can see that 6 is greater than 3. So again there will be a swap. And now 3 will be here and 6 will be here. So actually this is complete pass 1. Okay. And after the pass of pass 1, after the completion of the pass 1, you will notice that the largest element of this list is 6, which has come to the end. So in bubble sort, at the end of every pass, the largest element will be at the end. So this is there. So we know that in the bubble sort that the largest element will be at the last. So next time in the pass 2, we are not going to take the elements from 2 to 6. Rather, we will take the elements from 2 to 3, because we already know that this position has come, this sixth element has gone to the largest. This 6 is the largest element and it has gone to the last. So there is no need to have the comparison here, right? So next in pass 2, we will take only 2, 4, 1, 3, right? And we will again apply bubble sort. So this is pass 2. Now 2 is smaller than 4, so there is no swap. We will compare 4 with 1. 4 is greater than 1, so there will be a swap. So I have put a tick mark here, and we have changed their position. Now we have 1 and 4 here. Now 4 will be compared with 3. 4 is greater than 3, so there will be a swaps. 3 will come here and 4 will come here. So this is complete pass 2. And at the end of pass 2, you notice that the largest element 4 is at the second last location. But according to this, it is at the last location. So we got the second largest element also. This was the largest element and this is the second largest element. Now in pass 3, the number of elements that we will take is 2, 1, 3. So I have taken 2, 1, 3, and again I will apply bubble sort. So 2 will be compared with 1. 2 is greater than 1, so there will be a swap. That's why I put a tick mark here. So 1 and 2. So the elements will be exchanged. Now 2 will be compared with 3. 2 is smaller than 3, so there will be no swap. And you will notice that out of these 3 elements, 3 is the largest, which has come to the last location. So this is the third largest element. Now in the pass 4, we are remaining with only 2 elements, and that is the reason why there will be no more passes anymore. Okay. So we will compare 1 with 2. 1 is smaller than 2, so there will be no swap. And in the last, we got 2 as the largest element. And there will be no pass because now we are left with only 1 element, and 1 element, there is no need to compare it with anyone, right? So we notice that in the end, the elements that we have got is 1 and 2 are in sequence. Then we had 3, 4, and 6. So all the elements got sorted. You will write the output as the elements are sorted as 1, 2, 3, 4, and 6. So now you will notice that here, in this case, I have put a tick mark to the number of swaps. So you can see that there was one swap here, second swap here, and third swap here. Don't count it initially, just first of all focus on the passes and then count the number of comparisons and swaps later on after you have finished the passes. Okay, so you can see in pass 1, study this, the number of swaps, see the number of ticks here, 1, 2, and 3. So number of swaps were 3, and the number of comparisons, see, number of comparisons will always be n minus 1. So there were 5 elements, so the number of comparisons will 5 minus 1, that is 4. Now go to pass 2 and study the swaps and comparison. Here the number of swaps, there were 2 ticks, so 2 swaps were there, and the number of comparisons, how many elements are there? 4 elements are there, so number of comparisons will be 4 minus 1, that is 3. Now come to pass 3, here we have 3 elements, and we have put a tick, only one tick mark is there, so number of swap is 1, and comparisons are 2 because 3 elements are there. Now in the last we have, there is no swap, the swap is 0, and there is only one comparison, so I have written number of comparison is 1. So when you try to understand the number of comparisons, you can see that when number of elements were 5, number of comparison were 4, number of elements were 4, number of comparisons were 3, number of elements were 3, number of comparison were 2, and when number of elements were 2, the number of comparison were 1. So number of comparisons will be n minus 1. As you can see, the number of elements are n. So in the first part, the number of comparison will be n minus 1. In second part, the number of comparisons will be n minus 2. Similarly, in the last pass, there will be only one comparison, and second last will be 2 comparisons. So if you add the series, it will be n into n minus 1 by 2, and it will be n square minus n upon 2, and then you write n square by 2. You will leave the lower, you will ignore the coefficients and smaller terms, and you will take the highest degree term, that is n square. So the time complexity of bubble sort is order of n square, right? So if this question, so I have written here the time complexity of bubble sort is order of n square. So if this question comes in your exam, you have to actually explain like this only with the help of the passes. So it shows that you have complete knowledge about the sorting technique, and those who will not be having good knowledge, they will simply write the answer or some 1 or 2 passes and they will stop the process. So they will not get good marks. Now let's discuss the best case and worst case of bubble sort. Now let's understand the best case. So the best case is when the elements are already arranged in ascending order. So if this question also comes, let's say if I am asking you in the exam, what is the best case of bubble sort? So in that case, don't simply write that the elements should be in ascending order. Rather, you should also explain the example also. So I have taken 5 elements which are already in ascending order, that you can see 1, 2, 3, 4, 5, n is equal to 5, and elements are in ascending order. Now let's understand the procedure of bubble sort. Now in pass 1, what will happen? I'll compare 1 with 2. They are in ascending order, so no swapping. Now 2 will be compared with 3. Again, they are in ascending order, no swapping. Now 3 will be compared with 4. Again, they are in ascending order, so there is no swapping. And 4 will be compared with 5. There is no swapping. So in the end, you will see that if in the pass 1, you see that the number of swaps is 0. You can see there is no swap happened in pass 1. It means that the elements are in ascending order. So we will stop after the pass 1 only, because we got to know that the number of swaps are 0. So here, how many comparisons happened? Number of elements were 5. So number of comparisons will be n minus 1, that is 5 minus 1 is equal to 4. So number of comparisons are 4, but here there was no swap. Swap was 0. So here the time complexity will be, now according to the number of comparison is n minus 1. We will remove the coefficients, so the time complexity will be order of n, and number of swaps time complexity will be, there is no swap at all, so order of 1, that is constant time. So the best case is when the elements are in ascending order. Here the number of comparisons are order of n, and the number of swaps are order of 1. But in the previous case, in general case, the bubble sort, the number of comparisons are going to be order of n square, but in this special case, it has reduced to order of n. Now let's discuss the worst case. Now let's discuss the worst case. I have taken 5 elements, n is equal to 5, and the elements are arranged in descending order, 5, 4, 3, 2, 1. Now you will apply pass 1. When you will apply pass 1, you will see that 5 will be compared with 4. So they are in descending. 5 is greater than 4, so there will be one swap. Then the elements will be exchanged. Then 5 will be compared with 3. 5 is greater than 3, the elements will be swapped and they will be exchanged. Now we have 3 and 5. Then 5 will be compared with 2. Then 5 is greater than 2. The elements will be exchanged. It will be 2, 5. And 5 will be now again compared with 1. And they will be exchanged, swapped. So it will be 1 and 5. In the end of this pass, you will notice that the largest elements has gone to the end. You can see that how many comparisons will happen. Number of elements are 5. So number of comparisons will be 5 minus 1, that is 4. And swaps also in this case are 4. Right? In pass 2, we will ignore the last element and we will have 4, 3, 2, 1. Again, 4 will be compared with 3. So there will be one swap. Then 4 will they will exchange their position. 4 will be compared with 2. There will be a swap. Then 2 and 4. Now 4 will be compared with 1. Again, there will be a swap. So you can see that second largest, the 4 has reached to the end of the list. So second largest element is 4. Here number of comparisons, as number of elements are 4, number of comparisons are 3. And similarly, we have seen that there are 3 swaps. So similarly, now in the next pass, we will not take 4. We will take 3, 2, 1. Again, 3 will be swapped with 2 and then 3 will be swapped with 1. So again, the largest element is at the last. So we will not take this. And here number of swaps are 2 and comparisons are also 2. In pass 4, we have 2 elements. There will be 1 swap and 1 comparison. So you can see that the total number of comparison in all the passes is, here it was 4, then 3, then 2 and 1. 4, 3, 2, 1. But in general, if there are n elements, then it will be n minus 1 plus n minus 2 up to 2 plus 1. That is n into n minus 1 by 2. And the time complexity will be order of n square. And in case of number of swaps also, it will be 4 plus 3 plus 2, 1. You can see that they are always equal. So that will be also n square. So you can say that in worst case, the total number of comparisons is order of n square and the total number of swap is also order of n square. So the total time complexity is equal to number of comparisons plus number of swap, that is order of n square only. So in this way, you have to discuss the best case and worst case of any particular sorting algorithm if it is asked in exam. So this was all about bubble sort. So in the next video, we will discuss the next sorting algorithm. Till then, thank you so much.